the last large tract of virgin territory in the country today. Its wild animal population still thrives. But man's claim to the land is an old one. Mature settlements as much as 200 years old dot the Alaska shore. Americans have established themselves with that busyness which identifies their communities in the South. They have marked this spectacle of a land for their own. Human settlement had always hugged the most southerly Pacific shores. Beyond, into the north, endless miles of mountain, forest, and tundra had been scratched for food and for gold. But little had been permanent, until now. In 1867, when the United States purchased this land from Imperial Russia, it was considered by many to be folly. Certainly the Russians were not upset about relinquishing their fur posts. The price was considered good. Yet there had been stories of natural marvels. Deep in the high snowbound reaches of Alaska, strange black lakes that burn. United States geological surveys during the early 1900s followed up these fables, and the hunt for oil began. But there was still much oil elsewhere, and Arctic exploration was expensive and difficult. The potential oil fields seemed so remote. But as the 20th century rolled on, the attention of oil companies turned more and more to Alaska. Leases were purchased from the territory, then from the new state. With the looming energy shortage, the search grew more intense in the late 60s. In January 1968, on the remote north shore of the Great Land, years of effort paid off. The biggest known oil pool in North America, nearly 10 billion barrels of crude, was tapped almost 2 miles below the Arctic seacoast at Prudhoe Bay. Oil, 500 miles from populated Alaska, over 2,000 miles from the oil-hungry markets of the lower 48 states. In this climate, on this terrain, any kind of oil transport seems impossible. After studying many options, leaseholders decided on a pipeline which would thread its way 800 miles down from Prudhoe Bay to the ice-free port of Valdez. The concept was overwhelming. 8 energy companies would join in building the line, the most costly construction project ever undertaken by private enterprise. But it must be acceptable ecologically and have minimal adverse effect on the delicately balanced animal and plant life of this subpolar wilderness. The company formed to build the pipeline would be named Alaska, or the Great Land itself. Supplies and equipment were flown in and stockpiled. Then activity stopped, while the courts and Congress decided native rights and conservation questions and defined oil company responsibilities. Not until the spring of 1974 could the pipeline project legally proceed. First priority in this vast wilderness, a road to link Prudhoe Bay with an existing state highway at the Yukon River, 360 miles south. On April 29, 1974, heavy-duty machinery, men, and supplies flown into campsites along the route began pushing through the wilderness toward each other, laying a gravel roadway where few people had ever been. Specially selected material sites along the route supplied the thousands of tons of gravel necessary for the massive project. 154 days later, the road was completed. A 28-foot wide ribbon of gravel, an indispensable link with the outside. The crews gathered at the Koyukuk River to watch bulldozers push the last loads of gravel together. The great machines were hardly clear of the road when the vital traffic of the north took over the new route. But there was one more barrier, the Yukon River itself. The mighty waterway is Alaska's natural highway, crossing the heart of the great land from east to west. But for the pipeline operation, it was the last barrier to a man-made north-south route. It would be overcome with a bridge, the first permanent one on the river. The supporting piers will withstand all that nature can hurl against them. The crash of ice floes during spring breakup, high winds, extreme temperatures, earthquake, and flood. During construction, a winter ice bridge carries the giant trucks and their supplies to the northern camps. In summer, hovercraft barges link the Yukon shores. There are 29 construction camps along the pipeline route. Each is a self-contained community of up to 3,000 persons. Their major link to the outside world is the highway, which they helped to build. With the road completed, the facilities of the camps were quickly expanded with portable units and equipment hauled in over the new highway. 20,000 people, men and women from Alaska and the lower 48, could now move on to the big job, the one they are all here for, building the pipeline. Inside the long modular prefabs, plans are reviewed, specifications checked, and the logistics of every operation gone over. The food is plentiful and surprisingly good, considering the remoteness of the camps. Dietrich Pass, 4,800 feet up in the Brooks Range, is the highest point in the pipeline route. Between the Brooks Range and Prudhoe Bay lies the North Slope, still thought to hide even more deposits of oil. Its table-flat surface is treeless tundra, populated with caribou, which so far seem unafraid of their new neighbors. Hundreds of miles of pipe lie stacked and ready at Prudhoe Bay. Pipe, heavy materials, generating plants, prefabricated buildings, drilling supplies were brought by barge each year during 5 brief weeks of summer navigation. At Prudhoe Bay, several wells are drilled from each surface location. After drilling through the permafrost, a 2,000-foot layer of permanently frozen ground, which must not be allowed to thaw, the drill is directed in an outward curve, tapping oil as much as 1.5 miles distant from the rig. This reduces the number of well sites required, thereby minimizing environmental disturbance. The oil is hot and under pressure. Wells are capped with valves to await completion of the pipeline. Oil will flow from each well through a system of raised gathering lines to separation centers, where the natural gas will be removed from it and pumped back into the ground, to be stored until a gas pipeline can be built. Drilling in the western half of the Prudhoe Bay oil field is directed from the Sohio BP Operations Center, where computers and telecommunication systems operate 24 hours a day. Locally known as the Hilton, the center offers a degree of comfort and luxury and warmth far removed from the real world outside. A few miles from the operations center, pump station number 1 is under construction. This is the first of 8 such stations that will initially line the route. Huge oil storage tanks, the size of football fields, are welded into place. Before it leaves Prudhoe Bay, the oil will be measured. This is important, as each company participating in the drilling owns a percentage of the oil. Sohio owns leases containing 5.1 billion barrels, more than half of the known deposit at Prudhoe Bay. From the tanks, the oil will be pumped at speeds up to 7 miles per hour through the pipeline to Valdez. It will take about 5 days to reach the ice-free port, where it will be stored in tanks similar to those where the journey began. From Valdez, tankers will take the liquid cargo to West Coast ports, over 1,000 miles to the south. Concern for the ecological health of the harbor has inspired elaborate precautions. Inbound tankers, filled with a stabilizing seawater ballast, will dock at one of 5 berths. The water will be pumped into onshore tanks, where it will be filtered and cleaned before being released into the harbor. This is a special pipeline, the largest crude oil line in the United States. The diameter of the pipe is 48 inches. Its wall thickness averages ½ an inch. Materials have been selected and suited to a wide range of climatic conditions. An outer coating and wrapping on the pipe controls bacteriological, chemical, or electrolytical corrosion. Most of the pipe was shipped to Alaska in 40-foot sections. Then at welding facilities, especially constructed at Fairbanks and Valdez, pairs of 40-foot lengths were welded into 80-foot units. The pipe is welded by machine, then inspected by X-ray. This double joint welding under controlled conditions saves time and money on the construction site. Outside, more pipe is cleaned in preparation for welding. Accumulations of ice and snow evaporate before the intense heat of the flamethrower. From the storage yards, the welded lengths are taken to 56 distribution points along the route. Special trucks take 3 80-foot sections at a time. The pipes are strapped securely between the diesel cab and a specially designed trailer, which tracks the rear wheels around turns in the same path as the front wheels. The trucks keep up a 30-mile-per-hour grind, feeding the intermediate yards a steady steel diet. Shipments of fuel, equipment, and materials give the route a constant traffic flow. At every level of the project, exact scheduling of each delivery is essential, as all aspects of the undertaking are interdependent. A late delivery of insulation could hold up the entire operation. By late autumn of 1974, crews were laying the construction pad, a strip of gravel paralleling the main road. In some areas, a special plastic foam insulation laid under the work pad protects the permafrost beneath and avoids the use of thousands of tons of gravel. On the Trans-Alaska Pipeline, 3 basic installation techniques are being used, depending on climate, topography, and soil conditions. The important concern is to prevent the warm, oil-laden pipe from damaging the surrounding landscape. Just over half the length of the entire system runs through stable terrain such as bedrock, sand, or gravel. In these areas, the pipe is buried. But where burial is impossible, the pipe is carried above ground on vertical supports, which are lodged in holes drilled deep into the permafrost. When they arrive on the site, the double joints of pipe are strung out in a line, roughly in the position they will finally occupy. In preparation for field welding, the pipe edge is beveled, ground, and heated. Then the 80-foot sections are placed together. Field welding is done by hand. Grinding removes any excess welding material. When the weld is completed, it will be inspected by X-ray. Some of the pipes must be bent to follow the route. Much of this machinery was specially built for the Alaska Pipeline, as no crude oil line yet constructed in the United States has been as large. On March 27, 1975, about 7 years after oil was discovered at Prudhoe Bay, the first section of pipe was installed at the Tonsina River. Because of initial and abiding public concern in the project, every aspect of construction has been open to press scrutiny. Reporters, cameramen, and photographers are as much a part of the Alyeska scene as truckers and welders. No other industrial project has been exposed to such intense scrutiny. At the Tonsina River, 1,900 feet of welded pipe were lowered by side-boom tractors into a ditch crossing the riverbed. In the floodplain, concrete saddles would keep the buoyant pipe submerged. Within 2 months, work on the Tonsina River site was complete, and crews could move on to the next link. "382 miles of delicate permafrost will be crossed by elevated pipeline. The pipe is placed onto crossbeams between vertical support members, then coated with insulation and covered with galvanized steel. To prevent thawing around the supports, special thermal devices are placed inside the structures to keep the subsurface ground frozen. There will be 142 valves along the route, which can stop the flow of oil in an emergency. At all times during construction, the ecological setting of the operation is of prime consideration. Environmental scientists are on hand in each section, investigating animal tracks, observing nature's reaction to this great technological undertaking. No effort is spared to ensure the continuity of wildlife along the right-of-way. A pump station and roadway were moved to avoid a peregrine falcon nesting area. Aircraft flights were restricted near Dall sheep breeding grounds. Pipeline construction is timed to avoid rivers during spawning seasons. These rare trumpeter swans will find their watery retreat untouched when they return next year. The whole project is subject to constant environmental quality control and surveillance. On the North Slope, the work teams are exposed to the most grueling weather conditions on the entire route. Even in summer, this is cold, often damp country. Giant backhoes scratch the soil, digging the ditch where the pipe is to be laid. Because of wind and rain, tents are lowered by crane over each joint so that welders can work relatively free from the elements. When a joint is completed, the tent is lifted and moved up to the front of the line. Then a series of machines envelop the pipe in layers of protective wrapping. A tightly wrapped inner tape is covered with an outer wrapping, a tough plastic rock shield, which protects against abrasion and penetration. As a final precaution, an electronic device checks the seal of the automatic wrapping. Tractors lower the line into its earthbound home, cushioning the descent on large inflated pillows until the earth has been replaced. Then the pillows are deflated and withdrawn. The logistics of such an operation rival those at Cape Kennedy. 20,000 people are employed, installing 98,000 sections of pipe, 800 miles of steel across some of the roughest terrain on Earth, including 3 mountain ranges and 34 major rivers. But upon completion, the most startling aspect of the pipeline will be its appearance. For over half of its length, it will be invisible. As soon as the bulldozers have completed their work, seeding begins. The ground will have a new plant cover again within weeks. This material site, no longer required, is being revegetated. First, fertilizer is spread, then grass seed, which will hold out against erosion until the natural vegetation can return. The temporary ground cover will gradually be replaced by native plants, specially adapted to local soil and weather conditions. After over a year of pipeline activity, the ecological balance of the region seems little disturbed. Many species were unperturbed and stayed in the area during construction. So it seems likely they will coexist with the pipeline itself when it is completed. Interest in the pipeline runs high around the world, but nowhere more than in Alaska. Longtime residents and newcomers alike absorb the latest reports from the line. Everyone has a theory of the economics, ecology, and sociology relating to the project.
But here again we realize that it's progress. It's something that we need. We needed it badly to bolster our economy.
I should say it's both good and bad.
Why?
I should say that it's good for the Alaskan people to finally get employed, and I think the reason why I think it's bad is because there's just too many people coming in.
I think we need the oil, but I think they should have planned a little further ahead with the human problems.
Well, I gotta say it goes both ways.
Economical? It's great. I think it's good.
I think it's good in some ways and bad in some others, I guess. I think it creates jobs, and I think it's going to be good for the United States.
Because we need the oil, and I think Alaska needs to be developed to a certain extent. I hope they'll be careful, but I think it needs to be developed.
Well, because we need the oil. We need the oil here in the United States.
I think it's going to be good as a whole for the United States.
Why do you think that?
Because it's going to cut down the necessity of depending on foreign powers for our energy.
The pipeline is being transformed from drawing board concept to reality. In 1977, it will be a part of the North. And the first oil from the Great Land will be on its way to energy-hungry markets in the United States.